had a couple of students inquire about a different new video for 7.4. It seemed to be giving people a little bit of trouble. So here's the new video. Now, what 7.4 is covering is solving quadratic equations. And quadratic equations are the ones that are x squared equations. So instead of solving for x, you're still solving for x, but you're going to get 2 answers instead of just 1 since the x is squared. This section goes over 3 different methods of solving these kind of equations. The first one is by factoring, which we actually did earlier in chapter 4 when we did our factoring section. Okay, so we'll do a couple of those. Then the second method is the square root property. But then the last method is going to be by using the quadratic formula. So if you want to pause and write those methods down, you can do that now because I'm about to get into the homework problems. Okay, on number 1, the first problems we're going to solve by the factoring method. So if you're solving by factoring, there's 3 steps. We've done these steps before, again, in our factoring chapter that we did earlier. You're going to set the equation equal to 0. Then you're going to factor. Then you'll set each of the factors equal to 0 and solve those. So I guess those are 4 steps. So let's look at number 1. It says solve 13b plus 7 times 6b minus 18 equals 0. So again, I said the first step is to set it equal to 0, which is done for us already on this problem. Okay. Our second step is to do the factoring. Well, if you look at these, that's already in its factored form, right? If it wasn't, I would see a b squared somewhere that would tell me I needed to do some factoring. But this is already in its factored form, so I'm jumping all the way to the third step, which is to set each of these factors, 13b plus 7, set them equal to 0. 6b minus 18 equals 0. And then solve each of those equations for the b. So here I will subtract 7 from both sides. So 13b equals 0 minus 7 gives me negative 7. And then I'm going to divide by 13. So I'll be left with b equals negative 7 over 13, so there's one of your answers, and then solve this one. So here you'll add the 18 to both sides to get rid of the minus 18. So now you've got 6b equals 18, and divide by 6 to get rid of that 6. So here, b equals 3. So negative 17 thirds and 3 are your 2 answers. All right, number 2. We've got v squared minus 5v minus 36 equals 0. So once again, here's my problem. It is set equal to 0. So step 1 is complete. This time I need to do the factoring on my own. So again, if I'm going to factor this, I need to remember all my different factoring methods. This one has 3 terms, which makes it a trinomial. And remember, we had good and bad trinomials. The good ones started off with just v squared instead of a number in front of the v squared. So this is a good one. Since it's v squared, it jumps straight to v and v. Now remember our calculator trick, because what are we trying to find? We're trying to find the way to multiply to get negative 36. Using the same numbers, add to get negative 5. So remember, that's when we went to our y equals on our calculator. And what are we going to put in our y equals? This number right here, that negative 36. And then put divided by x. So that's what your first y equals should look like. And remember, your second one is going to look just the same as that one, except put in a plus x at the end. So negative 30, oops. Go down to the second y equals negative 36 divided by x plus x. So again, it should look like this. Then hit second table. So let's look here. What number are you looking for in this calculator? Remember, you're always looking for this number that's in the middle, that negative 5, in your second y column. So let's go down until we see the negative 5, which I have highlighted there, which means the numbers that are in the row with the negative 5 are the numbers you're going to use, which looks like a negative 9 and a positive 4. So minus 9 plus 4. Again, multiplies to negative 36 and adds to negative 5. After you do your factoring, again, just like the last problem, you'll set each factor equal to 0. So if I set each of those equal to 0, solve them for v. So this one I need to add the 9 to both sides. So v equals 9. Here I need to subtract 4 from both sides. So here I'm left with v equals negative 4. So 9 and negative 4 are your two answers. All right, number 3. Two y squared minus 7y plus 5 equals 0. So once again, our equation is already set equal to 0. I need to factor it now to see if it factors. So this one again is another 3 terms, so a trinomial. This is a bad kind though, right? Because it's not just y squared, there's a number in front of the y squared. That made this the longer type of factoring that we did earlier in the semester. So I need to multiply my outside numbers together. So 2 times positive 5, which is positive 10. And then we made our little t-chart. Now, instead of the 5 going in our y equals, now we put the 10 in our y equals. So go to your y equals again and clear it out. So this is what we're using because we're trying to find the numbers that multiply to give me 10 and add to give me that negative 7. So let's see, I got 10 divided by x and 10 divided by x plus x. So here's what your 2y equals should look like. Second table, so let's see, what am I looking for in my second y column? I'm looking for that negative 7 that's in the middle. You're always looking for what's in the middle. So I've already highlighted it for you, which shows you that you're using what? Negative 2 and negative 5. Now remember, seems like forever ago, but we put these both over that 2y. And then we reduce what we can. Well, this negative 2 over 2 reduces to 1s. Negative 5 over 2 does not reduce. So everything's reduced. This is where my factors come from, bottom then top. So now that I've reduced this, the bottom is just that y. Up top, I have a minus 1. Here I have a 2y minus 5. Since I'm solving, that's still set equal to 0. So there's the two factors that you're going to use and set them equal to 0. So y minus 1 equals 0 and 2y minus 5 equals 0 and solve them for y. So here you'll add the 1s. So y equals 1. Here you'll need to add the 5 first, right, to get rid of the minus 5. So now you have 2y equals 5, and then divide by 2. So y, this other y is y equals 5 over 2. So 5 halves and 1 are your two answers. All right, number 4, 2x squared minus 26 equals 0. So here we're running into an issue because if I try to factor this, pull out a 2, right? But if I just pull out a 2, don't even write this down because it's not going to work. And put in parentheses what's left, I have x squared minus 13. So look here, I still have x squared instead of x. So I don't have those two separate factors that I can set equal to 0 to get my two answers. The reason is I couldn't pull out an x from that. So let's see if we can work this using the next method, which is the square root property method. Now, when you're solving by the square root property, you're trying to, if you can, you don't want it set equal to 0. That doesn't help you. You're trying to get the x squared by itself. So let's work on getting x squared by itself. So if I want x squared to get by itself, I need the minus 26 to go away with the plus 26. So now I have 2x squared equals 26. There's still something else I can do to get x squared alone. I can get rid of that 2 by dividing by 2. So now I have x squared equals 13. Now that x squared is by itself, once you get the x squared by itself, you're going to knock out this squared with a square root. So look at the left side. What happens is that square root knocks out that squared. So your x is alone now. So there's your x equals. Now, when you get to the other side, this is when you take the square root of this right-hand side, that's when your two answers are going to come into play. You're going to have a positive and negative answer right here. So go ahead and put that positive and negative, and then bring down that square root of 13. Now, you're going to see, like if this would have been a 16 or something, you could have changed that to positive and negative 4. But this 13, it just doesn't simplify. So you have two answers showing here. There's one answer is the square root of positive square root of 13. The other answer is negative square root of 13. So those are your two answers, square root of 13, comma, negative square root of 13. So that's the square root property method to solve. All right, let's look at number 5. (4x squared equals 44). Again, I'm going to use the square root method. I need x squared to be alone, which just means I'll divide both sides by 4. So now I have x squared equals 44 over 4, which is 11. And now I'm to the point where the x squared is by itself. So I'm going to square root both sides to knock out that squared. So I just have the x equals. And remember, when you square root the right, that's when you get your plus and minus answers. So let's see, if I bring down the square root of 11, can you simplify this in any way? Is it a perfect square number? It's not. And it doesn't have any, I can't even break it apart like I was earlier. So let's see, the two answers are square root of 11, comma, negative square root of 11. Number 6, 5x squared plus 35 equals 0. So looks like another good option to use the square root property. So let's try getting the x squared by itself. So I will subtract the 35. So now I have 5x squared equals negative 35. Divide both sides by 5. So now let's see, I've got x squared equals negative 7. So x squared is by itself, so I'll square root both sides to knock out that squared. So x equals, again, positive and negative is what comes into play here, square root negative 7. So this brings up something that we saw in 7.3, which in this case, I can't leave my answer with that negative underneath that radical which means what is the number, not the, well, I guess it's the number and the letter. What am I pulling out of here to turn that positive? I need positive and negative I square root of 7. Now, I'm pretty sure your math lab will have a fancy button like this. You could type your answers in together with that plus minus button and just type in plus minus I square root of 7. If you want, you can type in I square root of 7, comma, negative I square root of 7 as your two answers. Number 7, x squared plus 64 equals 0. So on this one, again, looks like another good candidate for square root method. So get that x squared by itself by subtracting 64. So you have x squared equals negative 64. And then I'll square root both sides. And see what I have left. There's my x equals, here's where my positive and negative comes in. Bring down the square root of negative 64 and see what you can do with it. So look at this one. I'm definitely going to pull out the I to make it positive 64, right? Pulling out the I is what turns that negative into a positive. But look at 64. That is a perfect square. What is the square root of 64? It is 8, right? 8 times 8 is 64. So let's see. I'm going to have positive and negative. If this is an 8, I have I times 8, which is better stated as positive and negative 8i. So 8i and negative 8i are your two answers. Now, I want you to look at number 8. I'm going to write number 8 and then also rewrite number 5 up here and explain to you why there are different kinds of problems. All right, number 8 says 2w squared equals 16w. Number 4 that we worked earlier said 4x squared equals 44. So why am I going to work these differently? I think this one's a good candidate for square root property, which is how we worked it. We got the x squared by itself. This one is not, because if I divide both sides by 2, don't do this. Don't write this down. I have w squared equals 8w. If I tried to, again, don't write this down. If I tried to take the square root of both of those, it would be okay on the left, but look what you have on the right. Square root of 8w. You've still got that w in your part of your problem. So it's not like it was when I could take the square root over here. So that's why it's different. It's different because of that w right there. So if you're looking at this, you could see both of those terms have a w, which means they have a w in common, right? Well, since they have a w in common, let's solve it by factoring, because I know I'll definitely be able to pull out a w, right? If they both have a w, I'll be able to factor that out. But so the steps to solving by factoring are to set it equal to 0. You don't want w squared by itself. You want to set it equal to 0. So I'm going to subtract that 16w from both sides. So on the right side, I'm going to have a 0. Now, on the left side, this minus 16w can't combine with this w squared, right? They're two separate terms. So you're just going to have 2w squared minus 16w. Now, again, like we said, the reason we brought this term over here is because it had a w just like this one. So let's solve this by factoring. There's two terms, and they both have something in common. What goes into 2 and 16? A 2 does. And they also both have a w. So I'm pulling out that 2w. So let's see what's left after you pull a 2w out of each of these. Well, if I pull the 2 out, I pull the w out. On this first term, I'm just left with w minus 16 over 2 is 8, and I pulled out that W, equals 0. So now let's see, here's my two factors that I'm going to set equal to 0. So 2W equals 0 and W minus 8 equals 0. Remember, that's the next step to the factoring. After you pull everything to one side, set it equal to 0, do your factoring. So there's my factors. Set each factor equal to 0 and then solve them for W to get your two answers. So since this 2 is hooked on, to get rid of it, I'm going to divide by it. So W equals 0. To get rid of this, since that's minus 8, I'm going to plus 8 to both sides. So here, W equals 0 plus 8 gives me 8. So 0 and 8 are your two answers. All right, let's look at number 9. Three W to the third minus 20y squared minus 7y equals 0. So the first thing that I notice about this problem is that all those terms have a y. They don't have anything else in common, but they do all have a y. So I'm going to pull out that common term of y. Oh, sorry, not W. Sorry, they're all y's. Okay, so 3y cubed minus 20y squared minus 7y. So again, they all had the y, so I pulled it out. So essentially, they're all just going to lose an a y. If I'm pulling a y out, everybody loses a y. So 3y squared now minus 20y minus 7 equals 0. Now, look what you're left with in those parentheses, okay? I noticed that it's a trinomial, a y-squared trinomial, but it's the bad kind, right? Since there's something in front of that y-squared. So I'm going to use the long factoring method and multiply my outside numbers. 3 times negative 7 is negative 21. Here's the number that goes into your y equals. So go to your y equals and type in negative 21 divided by x. Negative 21 divided by x plus x. So here's what your y equals should look like. Second table, what are you looking for? I'm looking for negative 20 in that last column. So I've already highlighted it. So the numbers that are in the same row as that negative 20 are what you're going to use, which looks like a negative 21 and a positive 1. So negative 21, positive 1. What am I putting them over? 3y. Reduce. Let's see. Negative 21 over 3 reduces to negative 7. Positive 1/3 is good. So let's see, what are my factors? Let's see, now that I have reduced this one, what's going to be left? In the bottom, a y. Up top, I have that minus 7 now. Here, I've got 3y plus 1. Now, don't forget, we actually have another factor in this problem, right? Look, go back up. What did you pull out at the very beginning? This y, before I did anything. So it's still there. You still have a y out front from the beginning. So you're actually going to have 3 answers to this problem. That's what that y cubed told me. Here's your 3 factors that you're going to set equal to 0. So you're going to have y equals 0, y minus 7 equals 0, and 3y plus 1 equals 0, and solve them for y. This one's already solved for us. Y is already by itself. So one of your answers is 0. The second one, it looks like I need to get rid of the minus 7 with a plus 7. So y equals 7. And this one looks like I need to get rid of the plus 1 with a minus 1. So 3y equals -1. So I have -1 here. I still need to get rid of this 3, and since it's hooked on, I'm going to divide by it. So here, y equals -1/3. So my 3 answers are 0, 7, and -1/3. Okay, number 10 and 11. Looks like they're giving you graphs and asking you what the x-intercepts are and then what are the zeros. So let's see, number 10. So it gives you this U-shaped graph, this U parabola. It's called a parabola. So this right here, what it wants to know are the x-intercepts first. So what you're doing is you're enlarging that graph to see if where, and here's my x-axis right here, where does this graph cross the x-axis? Well, the first point it looks like it does is right here, which is at -1, right? But remember, when you're talking about an x-intercept, you're talking about a point. Okay, a point doesn't just have a number. It's got an x-coordinate and a y-coordinate. Its x-coordinate is wherever it crosses, so it's at -1. Its y-coordinate is always 0. So there's one of the x-intercepts, comma. Same thing here. Where does that one cross? It crosses at 3, 0. So there's the other x-intercept. Now, those are the 2 answers that go on your x-intercepts. The B part of the problem says the zeros are blank. Well, when you're talking about the zeros, you're just talking about the x-coordinates of those intercepts. So you just put in -1, 3. They don't have parentheses around them because it's not a point. You're not naming an x and y coordinate. You're just naming those 2. They're called zeros or solutions. Okay, so just the x numbers of those 2 points right there. So -1 and 3. All right, number 11 is the same kind of problem. It's going to give you a picture of a graph and then ask you for the x-intercepts and the zeros. Looks like this one is upside down. Doesn't matter. Whoops, I missed it. So, x-intercepts. Let's see, there's 2 of them, right? Because it crosses the x-axis in 2 spots. So let's see, 1, 2, 3, 4. So this first one is at that -4, 0. 1, 2, 3. That one crosses at 3, 0. So those are the 2 x-intercepts, the points. Again, those are the ones that are in the ordered pair parentheses because they're talking about the physical points. But when you're talking about zeros, you're just talking about the x numbers of those. So the answer would just be -4 and 3 with no parentheses. Okay, it looks like 12 through 16 are all quadratic formula problems. So somewhere on your paper, maybe even in a different color, write down what the quadratic formula is. I can't see that very good. I'm just going to write it in black so you'll be able to see it. Okay, this is the quadratic formula. Okay, this says I'm going to call it the opposite of B instead of saying the word negative, because the word negative sometimes will mess people up when we're talking about different positives and negatives. So I'm just going to call this the opposite of B plus minus the square root of B squared minus 4AC all over 2A. So put that somewhere on your paper so you're going to be able to refer back to that throughout this whole section. So let's see. Number 12. You've got x squared minus 7x equals 44. So the first thing you're going to want to do when you're using the quadratic formula to solve quadratic equations is set your equation equal to 0. So I need to subtract this 44 from both sides. So the minus 44 doesn't have a like term over here, so it's just going to slip in and make a third term on that left side. So I've got x squared minus 7x, just slide the minus 44 in there, equals 0. Once you have done that, you are going to choose your A, B, and C. So A is always the number in front of x squared. So let's see, what's in front of x squared? You just don't see it. It's a 1. B is always your number in front of x. It's sign with it. So that's going to be -7. And C is the constant, which is this term out here, -44. Now, after you find your A, B, and C, you're going to replace the A's, B's, and C's in this formula with the number that corresponds to those A's, B's, and C's. So the first thing I'm going to need is the opposite of B. So see why I'm saying opposite? Because when you come down here and you see the B is -7 and this is -B, it can be kind of confusing. So whatever that we're going to call, well, the first thing I want to plug in is what I need the opposite of B. So what would be the opposite of this -7? +7. So I'm going to have 7. Then the plus minus, that's what's going to give you your two answers. Then you're going to have this long square root with a bunch of stuff underneath it. So let's see, the first thing underneath it is I need my B number, which is -7. But I need to square it, which just means multiply it times itself. So B squared means -7 squared, which is +49. Now, if you're squaring a number in your calculator, you need to make sure you put it in parentheses, because if not, look at that top one. If you just put -7 squared, it's going to tell you -49. But you really need the negative in parentheses. So you want to have in parentheses -7 and then square it to get the +49. Okay? So just make sure that you put your number in parentheses when you square it. Now, this is a -4 that's part of the formula. So I'm just going to bring it over. And then your A and C. Running out of room. So what is A? A is 1. And what is C? Let's see, -44. So under here, I've got 49 minus 4 times 1 times -44. And then what's the bottom of the formula? 2A. So 2 times, what's my A? 1. So I've plugged in all my numbers. The next thing you're going to do from here on out is just simplify, simplify, simplify. The very next step always is to multiply from that -4 to the end right there. So let's just bring this other stuff down. So the 7 comes down, plus minus, square root, even bring down that 49. Now, don't bring down the minus. What I want you to type in your calculator is exactly what you see there. So -4, parentheses 1, close, open parentheses again, -44, close. So type in exactly what that says, -4 times 1, right, times this 1, times negative 44. And let's see what you get. When you hit enter, you get a positive 176. So that's why I didn't want you to just bring down the minus, because a lot of times when you multiply this negative 4 to the end, you actually get a positive number answer. So I'm putting in plus 176. And in the denominator now, what do I have? I've got 2 times 1, which is 2. So let's see what happens after this. How can I simplify this now? Well, I can add the 49 and the 176 together. So 176 plus 49 gives me 225. Still over 2. So let's see. I want to see, can I take the square root of 225? Let's just see. Second, remember your square root is the blue on top of that x squared button. So to get to the blue, I got to push the second key first. So I'm going to do second square root 225. So the square root of 225 and hit enter. Well, it is a perfect square. It's not one that I normally think of because it's a little higher than the numbers I'm usually dealing with. But the square root of 225 is 15, plain 15. So let's see, I'm running out of room here. So I'm going to have 7 plus minus, well, the square root of 25 is just 15 over 2. Now, here's what happens. If this turns into a number that's not a radical anymore, like it did since it was a perfect square, you're going to split it into 2 fractions now, giving 1 the plus and 1 the minus, and then simplifying your fractions. So let's see what I'm going to have. I'm going to have 7 plus 15 over 2. And what's my other fraction going to be? 7 minus 15 over 2. Well, keep going. What's 7 plus 15? What is that? 22 over 2. So down here to 22 over 2, which reduces to 11. I can't do any, that's as far as you can go. So that answer is 11. What about this one? 7 minus 15 gives me negative 8. Whoops. Right, 7 minus 15 is negative 8. So all I did was the 7 minus 15, got the negative 8, it's still over 2. And what is negative 8 over 2? It is negative 4. So 11 and negative 4 are your 2 answers. Okay? All right, I'm going to write my quadratic formula smaller at the top so that I can have more space to work these problems. Okay, number 13, 6x squared plus 7x equals 24. I'm going to solve this one by the quadratic formula. So let's see, again, has to be set equal to 0 first. So before I can do anything by picking out my A, B, and C, I got to subtract the 24 from both sides and get my 0. So let's see, over here I've got 6x squared plus 7x. Again, that minus 24 is just going to slip in at the end, equals 0. So once I have it all to one side set equal to 0, then I choose my A, B, and C. So let's see, A is the number in front of x squared, so it'll be 6. B is the number in front of x, so it'll be 7, and C is your constant, which is negative 24. So let's plug it in. Let's see, what do you need first? The first thing you need is the opposite of B. So this time, what's the opposite of B? Negative 7. Plus minus. That big long radical. Underneath the radical, you need your B, but square it. What is this number squared? Well, 7 times itself gives you 49. And then -4, because that's just part of the formula. And then your A and C, right? That's what comes in the last part up here. So A is 6, C is -24. And you put that all over. The denominator is always 2 times whatever your A is, which in this case is 6. All right, let's see. After we plug in, what's the very next step every time? You're going to multiply those numbers together. So let's see, I've got -7 plus minus the square root. Just drop down to 49. Now remember, just type in exactly how you see that. So you're going to have -4, open parentheses, 6, close, open parentheses, -24, close. Again, I'm typing it in exactly how I see it right here. -4, 6, -24. Enter. 576. And it's positive, so I'll put plus 576. Now look at what your denominator is. 2 times 6 gives me 12. Now the next step is to add these two numbers together. So 576 plus 49 gives you 625. So I've got -7 plus minus the square root of 625 over 12. Now let's see, just like the last one, I need to see, can I take the square root of that? I'm not familiar with 625. It's not one of the numbers that I'm generally used to when I'm talking about square roots. So type in second square root 625. So square root of 625. Hit enter. And look, it is a perfect square, right? If not, it would have given me a decimal. So I'm typing in, what is the square root of 625? It's just 25. So now I have -7 plus minus 25 over 12. Since this is not a radical anymore, that's when you split apart to your two different fractions. So -7 plus 25 over 12 and -7 minus 25 over 12, and then simplify those two. Oops. So -7 plus 25. Let's see, I want to type that in. I don't want to mess up. If I've done all this, I don't want to mess up there. So -7 plus 25 gives me 18. And it's over 12 still. So let's see, 18 divided by 12 gives me a decimal, right? So what do I need? What do I have if I have a decimal? What if I need, I'm not gonna let, it's not gonna let me type it in as a decimal. So you math enter that, right? Math enter to see that you get 3 over 2. So this reduces to 3 over 2. So there's one answer. Now, let's see, I've got -7 minus 25. Again, I don't want to mess up here. -7 minus 25 gives me -32 over 12. So I'm going to have to math enter that one also. So -32 divided by 12 gives me -2.66667. So I'm going to math enter that to get -8/3. So 3 over 2 and -8/3 are your two answers. All right, number 14. Four z squared plus 11 equals 16z. So again, solving by the quadratic equation. So I've got to set it equal to 0 first, which means I need to subtract 16z. So now let's see, what do I have? I've got 4z squared minus 16z. Oh, that's another thing I need to point out. When I subtracted that 16z, look where I'm putting it. I'm putting it in the middle of those two terms, right? Because you want to have your z squared, then your z, and then your plain number, right? Your plain number, this plus 11, comes at the end of that, equals 0. So now let's choose our A, B, and C. A is in front of z squared, so it's a 4. B is what's in front of z, which is negative 16. And C is your constant, which is 11. So let's plug it in. What do you need first? You need the opposite of B. So the opposite of this B would be positive 16. Plus minus. The first thing I need under my B squared, under my radical, is my B squared. So remember, when you're squaring, I need this number, that negative 16, but I need to square it. So what do I need to put that negative 16 in? Parentheses, right? So negative 16 in parentheses squared. So make sure you have it in parentheses. Hit enter to get 256. So B squared was the negative 16 squared, which is 256. What comes after that? Negative 4. And then your A and your C. What's A and C? 4 and 11. All over. Your denominator is always 2 times whatever A is. In this situation, A is 4. After you plug in, remember it's negative 4 to the end right there. And again, you type it in exactly like you see it. So negative 4, open parentheses 4, close, open parentheses 11, close. So again, it's exactly like you see it right here in your calculator. Enter. Let's see. This time it is negative, so it's going to be negative 176. So let's see. We've got 16 plus minus the square root, 256. This time, since it was negative 176 from this mess right here, I'm going to type in minus 176 over, what's your denominator now? 2 times 4 is 8. So let's subtract this now. 256 minus 176 gives me 80, which makes this a much more difficult problem. So y'all keep going down. I'm going to erase what I have up here so I can write it big and clear. So all I'm going to do now, since I subtracted 256 minus 176, that's going to turn into an 80 under here. So I've got 16 plus or minus the square root of 80 over 8. Now, when you try to take the square root of 80, second square root 80, and hit enter, it gives you a decimal, which means 80 is not a perfect square like our last problems have been. But here's the unfortunate thing that 80 will do. 80 does have multiple perfect square factors. So what I want to do is find numbers that multiply to give me 80. So remember, we can cheat on that and go to your y equals and completely clear it out. And type in 80 divided by x. That's the only one you're going to need. Second table. So let's see. Here's all the ways to multiply to get 80. What I'm looking for is my highest perfect square factor. So let's see. 1 times 80 I don't use. Even though 1 is a perfect square, it doesn't help us. So let's go down to the next one. 2 times 40. Neither one of those are perfect squares. That one is a decimal, right? Because I don't want to use any decimals. Look at this next one. 4 times 20. 4 is a perfect square. But here's where you have to be careful. Look at the next one. What do you see there? 16 is also a perfect square. So what you want is you want to choose the highest perfect square, which is that 16. So what you have to be careful with, so I'm breaking this 80 up into 16 times 5. We did this earlier in the module, or in the module before this. So you have 16 plus or minus. I'm breaking the 80 up into its perfect square and leftover. That's 16 times 5. Still with an 8 in the bottom. Now, why did we do that? Because now, look what you have here. What is the square root of 16? It's plain old 4 without a square root around it, right? The square root of 16 is 4. So now let's see. I've got 16 plus minus. This turns into a plain 4. Bring down the square root of 5 over 8. One last step. The reason I can go one step further is once you have broken apart that square root and taken the square root of that perfect square, that 16, to get that 4, you look at these three numbers. If they can reduce, if there's a number that goes into all of those, you want the biggest number. What's the biggest number that goes into 16, 4, and 8? Well, 4 does, doesn't it? Let's see. I'm trying to find different colors here. So 4 goes into all these. 4 goes into there 4 times. 4 goes into 4 one time. And 4 goes into 8 2 times. So the finished product is, let's see, here I've got 4 now. Plus, minus. Here, that's 1 square root of 5. So you don't even need that 1, right? Because 1 square root of 5 is just the square root of 5. Over your denominator is 2. And you are done with that one. So, and again, you can type this all in at once. There is a plus minus button down there in your toolbox. You'll see a little button that you can push that says plus minus. So when you type this in, before you hit anything else, go down to your toolbox, hit the fraction, the one that has the blue box in the top and the bottom, because then you're going to type all of the 4. Then go back down into your toolbox and hit that plus minus button. Then hit the square root of 5, and then go to your denominator and hit the 2. Okay? 2 more, 15 and 16 it looks like. All right, let's work 15. Again, I'm going to rewrite my quadratic formula at the top. Opposite of b, plus minus the square root of b squared minus 4ac all over 2a. My problem is x squared minus x plus 10 equals 0. All right, the first good news is it's already set equal to 0, so I'm set up and ready to choose my a, b, and c. I didn't have to move anything around. Let's see, a is in front of x squared, so it's a 1. B is in front of x. What do you see here? It's a negative. You don't see it, but it's a 1, right? So a negative 1. C is your constant, which is 10. So let's plug these into our formula. What do you need first? You need the opposite of b. So what's the opposite of this number? The opposite of negative 1 will be positive 1. Then your plus minus. Then your square root. Under your square root, what do you have? B, but square it. What is negative 1 squared? Well, negative 1 squared means negative 1 times itself. So negative 1 times negative 1, which is positive 1. Then the negative 4 from the formula, and then your A and C. A and C are 1 and 10. All over 2 times A, so 2 times 1. So let's see, after you plug in, what do? You have negative 4 to the end. So if I multiply this negative 4 to the end, let's bring all this down. So I have 1 plus minus the square root. Drop down this first 1 under there, right? It's not included in what I'm multiplying. So here, if I multiply negative 4 to the end, and remember, you type it in just like you see it. So -4, open parentheses 1, close parentheses, open parentheses 10, close parentheses, to see what you get. So you get -40 when you type that in. So this right here, the -4 to the end turns into -40. 2 times 1 in the bottom is 2. All right, let's subtract this. 1 minus 40. So you have 1, this first one, sorry, plus minus. What do you get when you do 1 minus 40? You get -39 over 2. All right, here's the good news about this, is 39 is not a perfect square. And it doesn't even break up like that 80 did in the last problem. That's what made that last problem so long and so difficult, is the 80 broke up into 16 and 5. 39 doesn't break up. That's the beauty of it. But it is negative, and you don't want to leave your radical with a negative underneath, but we can just simply fix that by pulling out the I, right? That's how you turn that positive. So you have 1 plus minus, pull out the I, which makes that positive 39 under the square root, all over 2. And that one is done. 16, last one. (5x squared plus 8x) equals -5. Okay, so this one is not set equal to 0, so that's the first thing I need to do, is set it equal to 0. So I'm going to add this 5 to both sides. So now I have 5x squared plus 8x plus 5 equals 0. Remember, I just snuck it in at the end because it couldn't go with an x or an x squared, so I just put it at the end. Now you can choose your A, B, and C. A is the number in front of x squared, so it'll be 5. C is the number in front of x, which is 8. Oh, not C, sorry. It's a long section, isn't it? So A is the number in front of x squared, so it's 5. Then your 8 is in front of x, so it's B. And then your C is that constant, which is 5. So let's see. First thing I need, opposite of B. So the opposite of this B would be -8 plus minus. The square root, let's see, I need my B, but square it. So 8 squared, 8 times itself is 64. Then the -4 from the formula. And then your A and C, which is 5 and 5. All over 2 times A, which is 2 times 5. Okay, plug in the -4 to the end. So again, type it in exactly how it looks. -4, open parentheses 5, close, open parentheses 5, close. Whoops. So just like you see it. And let's see, what is that going to give me? It gave me -100. So I have -8 plus minus the square root. Bring down my 64 minus 100. All over, let's see, 2 times 5 gives me 10. So let's see, what's 64 minus 100? If I type in that in my calculator, I notice that 64 minus 100 gives me -36. So when this is going to turn into a -36 under here. So I've got -8 plus minus the square root of -36 over 10. Now, what do you notice about 36? It is a perfect square, isn't it? It's 6, right? The square root of 36 is plain old 6, because 36 is a perfect square, but it is negative. So it's not just going to be plain 6. What's it going to be? It's going to be 6i, right? Since the radical is negative, it'll be I. So -8 plus minus 6i over 10. One last step on this last problem. What do you notice about all three of those numbers? What do they divide by? They all divide by 2, which means you can reduce them. If I divide this by 2, I get -4. If I divide that 6 by 2, I get 3. And 10 divided by 2 gives me 5. So let's see, what are we left with? Up top, -4 plus minus, this turns into 3i over 5. So -4 plus minus 3i over 5, and we are done.